Hey y'all, welcome back to a lesson on scatter plots. You've heard the word scatter. Think about what it means. If someone says they're scatterbrained, I am very scatterbrained. I'm always doing one thing. Like right now, I'm doing this, I'm giving a test. So I've got my laptop with somebody here virtual. I've got another thing pulled up on this screen. So my mind is here, my mind is there. I'm trying to think about this lesson and make sure that I cover all the details that I need to be covering. I kind of have an outline here. So I get very scatterbrained. You've probably noticed I'm like, woo, all over the place all the time, watching my door because people knock while I'm recording this video. So what does scatterbrain mean? It means I'm all over the place. I'm here, there, I'm everywhere. So with scatter plots, what scatter plots are or not lines, they are points of data. We've got all this data that is scattered out on the graph. And sometimes there's a relationship between that data. And when we look at it, we like this one right here, we can see that it has a positive correlation. When I look at this one right here, I can see that it has a negative correlation. And then these points are just kind of all over the place. And we would say that there is no correlation whatsoever. There's no relationship. So think about what this means. A positive correlation means as X is increasing, Y is increasing. Some examples that I could give you is as I don't know, the longer I drive, the further miles I am away from home. So we'd have miles from home here, hours driving. So as long as I'm not driving in a circle back to my house, the more time that I drive away from my house, the further I'm going to be from it, then more miles. A negative correlation, thinking about still driving, would be miles driven and fuel remaining in my tank. So the more miles I drive, the more fuel that I use up in my car, so the less is going to be in my tank. So this would have a negative correlation. Some things that have no correlation whatsoever. Um, I don't know. Let's see. How many times my door opens and how many times I brush my teeth. There is absolutely no correlation with how many times I go in and out of my classroom door and how many times a day I brush my teeth. I brush my teeth usually morning and night. Sometimes I go in and out that door twice, sometimes 100 times a day, sometimes twice within a minute. So there's no relationship between brushing my teeth and opening and shutting that door. So that just kind of gives you an idea here. So let's look at a scatter plot. It says in football, the scatter plot here displays the height and the weight of the New Orleans Saints football players. Is there a correlation between their height and their weight? So down here along this x-axis is their height in inches. So a player who's 70 inches would weigh somewhere, who knows what, around 200 pounds maybe. So this is their weight in pounds. And you can see there kind of is a correlation. I mean, yeah, you have this guy that's 68 inches tall that weighs over 200 pounds. But for the most part, if I was to connect these with a line or draw a line that kind of passed through the data best, my lines are crooked, but you can see that it is going up. And that makes sense. You know, the taller someone is, typically the more they're going to weigh because there's more to them. They're taller, they need more muscle to support their height. They're going to weigh more, there's more body there to have weight in, if that makes sense. So how do we create this line of best fit and what would we do with it? That's the next thing I want to talk about. So first we take the information that we're given, we create a scatter plot. Then we draw a line to connect the points as best as we can, or a line that passes through the middle of the points. And then from that, we can pick out 2 points that lie on that line and write an equation. Why would we want an equation? Well, an equation allows me to make predictions to say, okay, let's assume I have a player who weighs 71 or is 71 inches tall. How much should he weigh? I can come up here to this line of best fit and say, okay, he should weigh just a little under 200 pounds by looking at this data. So then we have what's called linear extrapolation and linear interpolation. And you might be thinking, those words are over my head. I'm out of here. I'm over it. But think about the words exit, the EXT, ext. I guess it's not exit, but I think about exiting out the door. Hence, I put the picture of me walking out the door. Exit means to leave, right? It's going outside of the building. I'm exiting, I'm leaving. Well, extrapolation allows us to make predictions outside of the given range of data. Interpolation, inside, allows me to make predictions inside the range of data. So let's look at this example here. I have taken the time to take this table from your book, and I wrote the table out here, and then I created a scatter plot on Desmos. I just put all these ordered pairs in, and it put all these points here. So first, that was step one, was to create the scatter plot. And what this scatter plot represents is this table here shows the average cost of a jet boat in the years after 2000. So after 2000, 2001, the cost was 19. So 2013, the cost was up to $37,618. So that's what this represents. And we're going to use that information in this graph to write an equation and use that equation then to make predictions on the cost of a boat in 2005. And then we'll look at 2020 and then 2025 just for fun. All right, so first step, like I said, would be to make the scatter plot. I've done that for you. So our next step is to draw a line of best fit. A line of best fit passes through the majority of the points, and it's going to have some above it and it's going to have some below it. But for the most part, it fits the data. Okay, so then what we're going to do is we're going to pick out some points on this line and use that to write an equation. So I've got the point 2, 20,000. And everybody's is probably going to be a little bit different because we're not looking at exact, everybody's line would be a little tiny bit different because you might draw your line more through this way or, a little bit different slope. Just kind of depends. But this is to allow us to make predictions. It's not giving us an exact amount. It's used to make predictions. Okay, so I've picked my 2 points. Now we know that we can use that to find the slope, change in, hopefully you said y, over change in, hopefully you said x. So 35,000 minus 20,000 is 15,000 over 12 minus 2, which is 10. If I divide this, I'm going to get rid of one of those zeros. So I have 1,500 is my slope. So now we can write us an equation. Y minus a y coordinate, 20,000, equals, oops, that's not an equal sign, equals the slope times x minus the x coordinate. So we're going to go ahead and distribute and solve. All right, so I have put one too many zeros here. I went ahead and distributed, then added the 20,000 to both sides, and now I have my equation. So what that can allow me to do now is make a prediction for the year 2005. If you notice, my graph, 2005, skipped that year. We went from this would represent 2001, 2002, 2003, 2004, and then we jumped up. So 5, let's plug in a 5 for x and figure out what that is. So I've got 1,500 times 5 for 2005, 5 years after 2000, plus 17,000 equals 24,500. So you can see it's a little bit off because this would be a little bit less than that. And we would expect it to keep going up. So it's not exact, but that's pretty close, right? $24,500 for year 5. Okay, so then for 2020, this year, what would be the cost of a jet boat or whatever they're called? So that would be 20 years after. So I'm going to do 1,500 times 20 plus the 17,000 equals $47,000. $47,000. Of course, that doesn't take into account things that are happening right now when we're making these predictions. By the way, what was this prediction called for 2020, remaining outside? It was on the outside of our data. So this was called extrapolation, right? This 2005 was finding a value inside our data. So that was interpolation. But this is called extrapolation. And just for the fun of it, let's just Google what is the price of a jet boat. And what I was saying is that this doesn't take into account things that are happening in the world like COVID right now. prices jump dramatically. Like if you're building a house, the cost of materials got really, really high with everything that's going on with COVID because there wasn't as many people working in the factories to produce the materials for building a house. So, according to our information, we said it should be around $47,000. If you look at this, it said jet boats range from about 21,000 to 66. So if you take the average of those two costs, 66 minus 21 divided by 2, that's, that can't be right. 66 plus 21 divided by 2. I don't know why. That'd be 43.5. So $43,500 would be the average cost of a boat. And we said 47. So we were pretty daggone close with our making predictions and looking at those. So saving the best thing for last. That's it. You're done. The best thing for last is, woohoo, you made it through. You finished the lesson. I hope that I didn't bore you to tears with this. But again, scatter plots are important to know. It's important to recognize them, knowing the positive relationship, negative relationship. And then there's some information out there where there's no relationship whatsoever. Have a great day, guys.